All right, welcome to Intro to Inequalities. We're going to talk about the basics today of the number stuff. So greater than is where the mouth opens in that direction. Greater than or equal to is where the mouth opens in that direction, but it also has half of an equal sign with it. So that's what that line is underneath. Then we have the less than, which was where the mouth opens that way. And then we have the less than or equal to. So we have the mouth opening that way again, but we have half of an equal sign with it. One way that I kind of remember these is if it says greater than, then I start with the mouth opening this way, okay? Because the mouth always opens to the bigger number. So if it's greater than, your mouth always starts with like how that word starts. If it says less than, well, this less tells me that my mouth isn't going to open in this side. So that's how I know my mouth opens in the other way. I hope that makes sense, but that's just how my brain remembers it, and maybe it'll help you remember it that way too. We're going to list out if the following is true or false. So what you really need to know super well is the beautiful number line, okay? So your bigger numbers are all on this side, and your smaller numbers are all going in that direction. So let's look at number one. -9 is greater than 2. The mouth is opening to the -9. That's not true. -9 is smaller than 2 is, right? They're in 2, it's on the smaller side. So that's going to be false. Number 2, -9 is less than 2. Well, we know that is true, right? Because we said earlier the reverse was wrong. Number 3, 2 is less than or equal to 2. So because of the equal sign that's with this problem, this is a true statement. Okay, 2 can be greater than or equal to. That's the big part. Or equal to. So that means it can also be equal to itself. Now, if it said something like this, 2 is greater than 2, that would be false. You would need to have the half equal sign in order for this statement to be true. Trust me, I like to be evil, so we'll look out for that. Next up, we're going to list 2 numbers that make the inequality true and 2 numbers that make the inequality false. So we have x is greater than -3. So 2 things that make it true. Here's my -3. Stuff that's greater, well, we got -2 is greater, and we have -1 is greater, right? Both of those are in front of the -3 on the number line. 2 things that make it false. You want to look at what makes it false? Look on the other side. Well, -3 would also make it false, right? Because we don't have that equal sign underneath here. -4 would make it false, and -5 would make it false. All of those numbers here are not greater than -3. Number 14, x is less than or equal to 2. So what makes it true? Well, I got that handy dandy little half equal sign here. So 2 would make it true, kind of like how we did up here earlier. And let's see, we want less than it. So here's my 2. So 1 would make it true. We want the opposite. So that means 3 and 4 would not work as replacements, right? Because 3 or 4 are not less than 2. 15, we have a is less than -7. So what would make it true? So here's where -7 is on my number line. What makes it true is -8 and -9 are less than. Now, you don't have to do the numbers directly behind, right? You can just write big old numbers that would go behind it. You could write -20 for all I care, or a -100 million. Now I got to look for stuff that makes it false. So here's my -7. It has to be less than -7. We're making it false. So -6 wouldn't be an answer, and -4 wouldn't be an answer, right? Those are not smaller than -7. Now, here is a very important skill that we need to be very masterful of because we're going to use it a lot when we solve. So we're going to rewrite the inequality so the variable is on the other side. Make sure to flip the inequality too. I want you to do a squiggly line underneath that. So basically, if we have x is greater than -3, we're going to flip that around. We're going to flip-flop the location of the 3 and the x, and then we also flip the inequality. So if the mouth opens to my left, then it should now open to the right. And now it's been flipped. Same thing with this. We have 2 and x are gonna flip sides, and then my mouth opens to the right, so now I have to open it to the left. Don't forget the half equal sign. 27, we have a and -7 are flipping sides, and then I have to flip my sign here, so my mouth is still gonna open to that -7. So looking at these, in 25, x is what gets eaten originally, and it's still getting eaten when I flip it. 2 is what is getting eaten originally, and it's still getting eaten when I flip it. -7 is getting eaten originally, and it's still getting eaten when I rewrote it and flipped it. On the back here, we're going to do some math to the listed inequality and decide if it's still true or false, right? So all of these, you're using the -9 is less than 15, right? We're still using this for all of these. But now we have things we're going to do to it. So we're going to add 3 to both sides. So let me add 3 to this -9, add 3 to this 15. So we got -9 plus 3 is -6, and then we have 15 plus 3 is 18. So when I write out my result, I have -6 is less than 15. Is -6 less than 15? Check out my number line. -6, 15, 15 is bigger, so yes, that is still true. Then it says subtract 7 from both sides. So I'm gonna still have that -9 is less than 15, subtract 7 on both sides. So let's see, we got -9 minus 7 is -16, 15 minus 7 is 8. So we have -16 is less than 8. Let's see, here's -16, here's my 8. Yes, -16 is less than 8, so that is still true. So you're gonna go down this list and continue to figure out if it's still true as you do these maths here. Tomorrow we're gonna talk about what did you see when it became false. All right, that's the end of this video. The rest is you.